Hey everyone, ever wondered if you could tell the difference between a human-written essay and one generated by an AI? Well, researchers just did a deep dive into this question, and the results are both fascinating and a little unsettling. Let's start with the basics. Most AI text models like GPT use autoregressive generation, a process where the model predicts the next word based on what came before, one at a time. It's fast, but it has a flaw. Once a sentence starts to sound off, the model can't easily backtrack. That's where diffusion-based models like LLaDA come in. These systems work more like editors. They start with a rough draft and refine it step by step, revising earlier parts if needed. It's slower, but the results can feel more natural, almost like a human revising their own work. But how do we actually tell if a text is human or AI generated? The researchers behind this study used 4 key stylistic fingerprints to compare outputs. 1. Perplexity. This measures how predictable a text feels. Lower scores mean the model thinks the text is super easy to guess, like a robot writing a grocery list. Humans, on the other hand, tend to be more unpredictable. 2. Burstiness. This looks at how much sentence complexity varies. Human writing often has ups and downs, short, punchy sentences mixed with longer, more detailed ones. AI models, especially autoregressive ones, tend to be more uniform. 3. Grammar error rate. While humans make occasional mistakes, high-quality AI outputs usually have near zero errors. 4. Semantic coherence. This checks how smoothly ideas flow. Humans might jump between topics, but AI often creates text that feels too connected, like a robot with a script. The study tested 2 models, LLaMA, an autoregressive model, and LLaDA, a diffusion-based system. The results: LLaDA's outputs were much harder to detect. Why? Because it mimics human patterns better. For example, LLaDA's perplexity and burstiness scores were closer to human texts, and its sentences felt more naturally varied. Even grammar checkers struggled to spot it. But here's the catch: diffusion models aren't perfect. They sometimes reuse words more than humans do, leading to slightly less diverse vocabulary. And while they're great at preserving the original meaning, as shown by higher BLEU and Rouge scores, they can still be caught if detectors look beyond just perplexity and grammar. The big takeaway: relying on a single metric, like low perplexity, isn't enough anymore. AI is getting too good at mimicking humans. So what's the solution? The researchers are pushing for new tools that combine multiple signals, like analyzing how text is generated, not just what it says. They're also exploring cryptographic watermarks, which are like invisible fingerprints embedded in AI-generated text to track its origin. And here's where it gets really interesting. They're not just building better detectors. They're working on systems that can flag AI content in real time, even as it's being created. Imagine a world where every piece of text automatically gets a digital signature to prove it's AI generated, without changing the content itself. But this isn't just about catching cheaters. It's about building trust in AI. As these models become more powerful, we need strategies to ensure transparency and accountability. The researchers are already sharing their code and data openly, so others can build on their work. So the next time you read something online, ask yourself, could this be AI? The line is getting blurrier, and that's why this research matters. Want to dive deeper? Check out the GitHub repo linked in the description. Who knows, maybe you'll help shape the future of AI detection. Thanks for watching and stay curious.